Hello, Uggies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to talk about lightning arrestors. This question is from Jeff McFarlane, KD9ZSL, and he's got a little picture here of a lightning arrestor. He says, "Hi Dave, I picked up two lightning arrestors on eBay a little while ago. I went to install them, but I thought I should test them out and found a dead short in them. Maybe I am missing something. Take a look at the picture. Let me know what you think. Thanks, Jeff." The problem with the picture on this thing is it's a picture of the outside, and so you don't know what's on the inside. Now, there are three major producers of lightning arrestors used by hams that are serious lightning arrestors. One is Alpha Delta, other is Morgan, and the other is Polyphaser. And they're different inside, okay? So what I want to do is explore this Alpha Delta a little bit so you can see what's inside and see where you should see a dead short and where you should see an open. And then we'll take a look at the schematic of the Morgan, which is more complex, and then the schematic of the Polyphaser and see what's going on there. Okay, so let's take a look. Okay, so this is an Alpha Delta model TT3G50, which is extremely common in ham radio. You see these a lot. Okay, they're less than $100 or about $100. This goes to the radio, this one to the antenna, or the other way around, doesn't matter because the thing is symmetric. Now this has a lug right here. This is an aluminum block, so aluminum screw. And this right here connects to whatever connects to your ground rod. Usually you want to mount these right at the ground rod. Now let's look inside. We can take off the magic part. This little thing right here that is often soldered into here or not, you can just put it in, is a small gas tube, and what happens is it will arc over in this tube when the voltage is too high. Okay, and the ones that are the red on the outside are the ones that'll handle 250 watts, and the others will handle, the one with the black will handle like 1500 watts. And let's take a look at what is inside here. I'm going to put a little extra light on it so you can see it. It's literally a piece of wire going straight through center conductor to center conductor. And then you see where this gas tube sits right in here. You put that into this, okay, and it screws simply, and in fact they've got a rubber gasket around it, so it's watertight. And you always only thumb tighten these things. So if you have to replace a gas tube, you can. The gas tube is designed to fail short. So if you try to operate with it failed short, you'll show a very, very high SWR, and you'll know to go out and take a look at this thing. This is the simplest form right here. Now let's just do a check. Now from what we've seen, obviously the grounds touch each other. Okay, that's fine with a 0.1 ohm resistance. Okay, and the center conductors should have something about the same. And we see here 0.1 ohms. Okay. And if you check from center conductor to outer conductor, it should be, it's showing us at its limit, okay, in terms of megohms. So in the event of a high voltage there, that will arc across and send the current to ground, okay, thus protecting the radio. Let's take a look at some others. This is Alpha Delta. It's got a gas tube in it, so, and they're symmetric, doesn't matter which way they go in. Okay, so the antenna comes, it will fire the gas tube if the voltage is too high, then it goes to the radio. So nothing funny to short there. Now, if you look at the Morgan, here's your antenna going out to the antenna. Here's the radio coming to ground. Note this little coil right here. Okay, you've got a bit of a tuned circuit in here to make the thing fire fast. For example, if you have static buildup it will find its way to ground right through that coil there. Even like if it's on a dipole antenna and the center is the half that's not grounded, it can find its way to ground here. It will ground right here with the gas tube. Now it also has a DC open right here. This capacitor lets this through. Some antennas, like receive-only antennas, you need DC continuity through here. So you might be better off with an alpha delta. Here's a little resistor in here, another way to bleed charge to ground. Okay, on either side. The combination of this resistor, this capacitor, this inductor makes for a very broadband tuned circuit. Okay, and when it fires this to short, just like the other, but otherwise this is capable of taking out the resistance. Now let's go over here to the Polyphaser. And again, it has the Morgan over here. Here's the Polyphaser. Note that the Polyphaser does not allow straight DC to DC. Some antennas have active electronics on them, particularly receiving antennas have active electronics, and so you've got to get around that capacitor somehow. But it has the gas discharge tube here also. There's nothing in here that will bleed off the static charge on the antenna, except the gas discharge tube could fire long enough to get rid of that. Okay, so that gives you an example of how these things work. Different lightning arrestors work in different ways. So what we see is that different lightning arrestors, different commercial grade lightning arrestors, widely used, differ in important ways. However, they're all pretty good at what they do. Even the Alpha Delta, which is the one I was first introduced to. And now I'm using Morgan in the entry panel on the outside of the house. So there's lots of different choices. The Morgan, Polyphaser, and Alpha Delta are the three big reputable brands. As you can see, they're quite simple. There's nothing fancy about it. Now, these will fire for lightning. They're not good for like electromagnetic pulse or anything like that, but these are good for lightning, and that's what you need. Okay, so I hope that answers your question. Now, I couldn't tell the brand of this one that I found on eBay. There wasn't enough information for that. I recommend getting those three rather than others. I know MFJ made a real chintzy looking little one, and I've seen others. They're just not sturdy enough. Now you may say, good grief, this lightning arrestor is not big enough to shunt off an entire lightning strike. Well, the answer is that the lightning strike will find ground here. Okay, so the big surge will go down toward the ground rod. Okay. These little things that may seem to conduct only a little current, over a couple milliseconds will conduct a great deal of current and then proceed to heat up rapidly, but by the time it's going to melt, the lightning strike is over. So that's how these things work. So there you go. So Jeff, good luck with your lightning arrestors. If they are shorted center to ground, like the Morgans are, we looked at the Morgan here and it had that coil. So that will show a DC ground from center to the outer conductor. That should not happen on the Polyphaser or the Alpha Delta. And of course, I don't know what's inside of yours. So there you have it. A look at lightning arrestors. Something everybody should have. Now, I understand that lightning is more common in certain parts of the world than in other parts of the world. And some people who think they're in a low lightning area are sometimes tempted to leave these things out. You still need the ground connection to get that static and noise reduction effect. There's two reasons we ground. One is lightning protection and transients, and two is to help get a better signal when your system just wants to work with an antenna part and a ground part. It allows the noise that builds up, the common mode noise that builds up on an antenna lead, to find its way to ground. Okay? Now, if you are in an area where you don't have that problem, some people don't use them. I consider it amateur best practice to have lightning arrestors in your system all the time, even if you disconnect your equipment during lightning storms. I took a direct hit once, and I did a little damage to some of my equipment. Fortunately, my radio was completely disconnected and sitting on a shelf. So there you have it. I would encourage you to become subscribers, and if you would like, you can click the bell and get notifications of the new videos. That's if you have overall notifications turned on. It's sort of a double acceptance there. And if you would like to help support this channel, go to patreon.com/KE0OG. And until we next meet, 73.